Hello, friend. Settle in and let the day loosen its grip. Feel the pillow hold you, the room dim and kind, your breath moving like a small tide. Tonight we're going to drift into a soft corner of cosmology where space-time can fold like fabric, and pathways called wormholes might bridge faraway stars in a single quiet step. No hurry, no need to solve anything. Just let the idea rest beside you, like a lantern with the wick turned low. We'll imagine what it would mean to slip through a cosmic shortcut, how it might look, how it might feel, and what careful physics whispers about what's possible and what's still only a dream. The pace will be unhurried, the edges rounded, the science tucked into a lullaby, so your thoughts can float without snagging. If this gentle journey keeps you company, a light tap on like and subscribe helps other sleepy travelers find their way. For now, let your shoulders soften, let the clock fade to a friendly hush, and let's begin our night walk through the quiet doorways of the universe. Imagine a doorway that doesn't open into the next room, but into a hush of starlight halfway across the cosmos. One soft step, and distances that would take a beam of light millions of years become a few heartbeats of quiet. It isn't a magic trick. It's a possibility whispered by the mathematics that already gave us black holes, gravitational waves, and the bending of starlight. Those ideas sounded like fairy tales once, too, and then the universe nodded yes. So when we let the mind drift toward wormholes, tunnels through the fabric of space-time itself, we're not leaving science. We're letting science loosen its collar and speak in a calmer voice. The thought sits gently. Could there be hidden corridors knitting far-flung places together? Maybe even knitting moments together the way memory does? Somewhere, right now, might space be folding back on itself, like a blanket turned under at the foot of a bed? If such passages exist, could anyone, anything, ever use them without tearing the cloth they run through? To hold those questions, it helps to cradle the fabric they belong to. Space, in everyday life, looks like nothingness, the quiet between things. But under Einstein's lamp, that quiet turns out to be structure, not just the three lengths and widths and heights we move through, but time braided in with them, the four together called space-time. It isn't a stage where matter performs. It's the dance floor and the steps and the rhythm at once. Space-time can bend and bow. It can stretch, ripple, and knot. The sensation of gravity that presses you into the mattress is not a mysterious reach across emptiness. It is the shape of the floor under everything, curving around mass and energy. The image people return to is simple and kind to the imagination. A taut rubber sheet and a heavy sphere resting on it. Place a marble near that sphere, and the marble's path curves, not because the sphere has invisible fingers, but because the sheet itself dips. Planets move the same way, following the straightest possible paths through a geometry that isn't straight. They loop the sun because the sun reshapes the neighborhood, and the easiest way forward is a circle. This reimagining cleared fog from the cliffs of physics. If space-time can curve into wells, why not into bridges? If it can swirl into eddies that hold planets close, might it also fold so two distant regions come to touch? The equations do not scold us for asking. They leave room for loops and tunnels, for throats that connect here to elsewhere, maybe now to later. That is where the story of wormholes starts, not with a spaceship, but with pencil marks. In 1935, Albert Einstein and Nathan Rosen were studying the deep grammar of those equations. Their attention wasn't on shortcuts between stars. They were wondering whether the very idea of a particle could be rephrased as a wrinkle in spacetime instead of a little bead of stuff. While tracing that thought, a strange doorway appeared in the math, a bridge linking two separate regions, a tunnel the geometry could form all by itself. Two mouths, one on each side, joined by a throat and Einstein-Rosen bridge. The nickname Wormhole came later from an apple and a small traveler with a practical mind. Why circle the skin for hours when you can go through? It was a clean, beautiful solution, permitted by the same rules that had already pointed to black holes and the bending of starlight around the sun, ideas that the sky eventually confirmed. That permissive nod meant the bridge couldn't be laughed out of the room, but the bridge had a temperament. In the original form, it clenched, shut faster than light could blink. Nothing could cross. The tunnel existed only as a mathematical breath, there and gone, snapping closed the instant anything tried to lean on it. A bridge that collapses under the first footfall is still a bridge, but it isn't a road. For a long time, that was where the thought rested, allowed, but not usable, like a dream of a door that never quite opens. And then black holes, those other children of Einstein's equations, stepped into focus. Astronomers caught their signatures in X-ray flickers, in stars slung around invisible anchors, in the gravity-made rings of lensed galaxies, and later in the tremor of space-time itself, gravitational waves ringing from collisions far away. To understand wormholes, it helps to stand in the long shadow of a black hole and listen. A black hole begins with a star that has burned through the fuels that hold it up. Pressure falls away, and gravity does what gravity does. It gathers. The core folds inward. If the star is massive enough, no known pressure can halt the fall. Matter rushes toward a point where our current equations throw up their hands a singularity, not so much a physical pinprick as a signal that our map runs out of ink. Around that center sits a boundary called the event horizon. Cross it, and every path forward leads only inward. Even light cannot find a route back out. From the outside, a black hole looks like an absence, but it's more like a shape, a region of space-time with a one-way edge. For a long time, the imagination stopped there, an end of roads. But inside the same mathematics, there's another sketch, delicate and conditional, a throat leading from this trapped region to another place, or even another universe, paired with something like a mirror, opposite, a white hole where a black hole never lets light escape, a white hole never lets anything in. Linked together, they make a tunnel with an entrance and an exit, like two doorways built back to back through a wall. On paper, it's tidy. In practice, it's skittish. The throat is exquisitely sensitive. The moment anything, photon, dust, mote, traveler with a nervous laugh tries to pass, the geometry pinches shut. The very act of stepping onto the bridge disturbs it enough to make it vanish. That tension between permission and fragility became a recurring theme. The universe can host such structures in principle. It simply refuses to stabilize them in the forms we first imagined. Still, the mind lingers with the picture because it carries so many quiet promises. If a stable passage existed, a ship might thread it and arrive where light would need eons. Messages could cross gulfs that otherwise mute them. In some speculative portraits, the mouths could even sit at different times as well as different places, turning a corridor into a clock with a trick inside. These possibilities live near the borders where physics meets paradox, and yet they're not tossed out by the rules. They're fenced by them. To keep the thought gentle and honest, it helps to return to the fabric. Space-time isn't just a metaphorical sheet, it's a structure that responds to mass and energy with curves and slopes we can measure. We've seen its surface ripple when black holes merge. We've watched light bend around clusters of galaxies, their dark matter sculpting arcs and rings. We've timed the slowdown of clocks in deeper gravity wells, satellites correcting for that effect so your navigation stays true. The fabric behaves consistently, like linen that always shrinks the same way when washed. In that consistency lies our trust. If a tunnel through this cloth is to stay open, it must obey those same habits, not ignore them. The earliest bridges failed that test. They asked spacetime to allow a passage while pretending the passage didn't weigh on it. But everything weighs. Even light, which has no rest mass, carries energy and momentum. And energy tells spacetime how to curve, try to slip through, and the attempt becomes part of the story, tugging the throat smaller. There's a soft comfort in acknowledging limits without scolding the dream. The dream points us back to what is already real and astonishing. Black holes are not theoretical curiosities anymore. We have an image of one silhouette cut from the glow of swirling gas. We've caught the shiver of space-time when two such objects collide. The same mathematics that allowed all that also allows a passage brief, unstable, but not forbidden. That's not a tease, it's a signpost. It says, if a lasting bridge exists, it has to be supported by something the early sketches didn't include. The mind reaches for analogies. Dig a tunnel in dry sand, and the walls fall in unless you shore them up. Build an arch, and it holds only if the stones press just so, or if you add a keystone with the right weight. In space-time, weight means energy and pressure can be strange. Most of the everyday world features positive energy densities and pressures that squeeze rather than pull apart. To keep a throat from collapsing, you'd need stress of an unusual kind, something that pushes outward where gravity wants to pull in. That idea belongs to the next bend in the path, but you can feel its outline here, like the pressure of a warm palm through a blanket. Think of the apple again. The skin is the long way. The tunnel is the short way. The apple doesn't object if the tunnel is neatly lined. Without that lining, the flesh yields and the path closes. The mathematics hums the same tune. The geometry can permit a tunnel, but the tunnel is skittish, easily startled. Gentle light is enough to make it flinch. The smallest traveler becomes the wrong kind of guest. People sometimes picture the inside of a wormhole as a gleaming tube with stars streaking past. The more honest picture is quieter, a region where distances and times coordinate themselves differently, where every step is a negotiation with curvature. Nothing has to be violent or chaotic. It can be smooth, well-behaved, like flowing along a river that bends through hills you can't see from the surface. But that riverbed still needs to hold. Without the right support, erosion wins. All of this rests on the language Einstein taught physics, to speak a language where mass and energy shape geometry, and geometry shapes motion. It is a tender language for an old universe, and it has earned our trust by predicting so many surprising, measurable things. When it allows a bridge but then warns that the bridge gives way under the lightest touch, it isn't being coy. It's keeping us honest, inviting us to look for the missing brace rather than insisting the bridge can't exist. So we can keep the picture soft around the edges, two mouths adrift in the deep night. a narrow, shy throat between them. The possibility is real enough to deserve a lullaby, and the difficulty is real enough to slow the voice. Somewhere in that quiet, a question ripens: what exactly makes the throat tighten, and what kind of support could coax it to stay open without breaking the rules that keep the rest of the cosmos steady? And the answer lies in gravity's nature. Wherever gravity lives, things lean toward one another, not because the universe is possessive, but because space-time curls inward around energy and mass. A tunnel through that fabric shares the same instinct. Left alone, it narrows. Think of an arch of wet sand without a keystone or wedge, lovely for a breath. Then one small tremor and the doorway settles, the passage gone. Ordinary matter with positive energy and pressure only deepens that inward curl. To keep a wormhole open, something rare must play the brace, an outward-leaning support that gently opposes collapse while keeping faith with the laws that hold everything else together. To keep such a throat from sealing, something would need to push outward, steady and kind, the way a hand holds a door from swinging shut. Everyday matter can't do this job. Everything we know carries plus signs, positive mass, positive energy, and those make gravity attractive. The throat needs the opposite sign, not a pull, but a gentle outward pressure that coaxes the geometry to swell where it wants to shrink. Physicists call the needed ingredient exotic matter. It's not antimatter. Antimatter still weighs positively and falls like everything else. Exotic matter would have negative energy density, the strange kind of less than nothing that urges space-time to puff outward instead of curl in. We haven't found a nugget of that material lying around the cosmos. Every particle and every flicker of radiation we've measured behaves like a faithful citizen of positive energy. The universe, as far as our instruments can tell, doesn't stock shelves with wormhole-bracing lumber. Yet the quantum world, where a vacuum is never truly empty, keeps a small lantern lit. In a classic experiment called the Casimir effect, two metal plates, placed very close together in a vacuum, feel a faint nudge. Quantum jitters outside the plates are a touch livelier than the one squeezed between them, so the space in the gap holds slightly less energy than the space nearby. That difference acts like a tiny push, as if the void between the plates dipped below zero by a whisper. It's real, measured, and exquisitely small. People stretch that whisper into a daydream. What if a similar quantum, less than nothing, could be arranged around a wormhole's throat, forming a supportive lining that resists collapse? On paper, the direction is right. In practice, the price tag is staggering. Even timid estimates say the amount of negative energy required for a human-sized doorway would dwarf anything we can produce, steer, or store. It's like asking a single violin to hold up a cathedral. Without that support, wormholes remain what the equations permit, but the world doesn't build for us at scale. Legitimate structures, in theory, yet not ready-made paths through the night. Inside Einstein's theory lives a simple, famous example, the Schwarzschild wormhole, born from the same mathematics that describes a non-rotating black hole. Picture two regions of space-time that could be far apart in our universe, or not even in the same universe at all, linked by a throat. It tempts the imagination. Step into the first mouth here in our galaxy, and step out from the second mouth in some glittering spiral billions of light years away. Your personal clock would barely clear its throat. The wish meets two refusals. First, The Schwarzschild throat collapses too quickly for anything to pass. It exists as a blink, there and gone before a single photon can slip through. Second, even if you could prop it open for a moment, the gravity gradients near a black hole would treat a traveler unkindly. Gravitational pull changes rapidly over short distances, the tug on your feet stronger than the tug on your head if you're falling feet first, and that difference stretches and squeezes. In the slang of astrophysics, it spaghettifies. Well before any supposed exit, atomic bonds would be torn. A bridge you can't cross is still a bridge, but not a road. So the gentle question arises, could there be a kinder structure? One with a wide, steady throat and tides so soft they feel like a small boat rocking on a lake? In the late 1980 seconds, that question found a careful listener. The astronomer Carl Sagan wanted a scientifically honest way to send a character across the stars for his novel, and he asked physicist Kip Thorne whether general relativity had room for a passage that a person could actually survive. Thorne, with his student Michael Morris, took the request seriously. They combed the equations, looking for a configuration that would remain open long enough, be wide enough, and keep tidal forces gentle. Their answer was conditional and precise. Traversable wormholes are allowed by the laws as we understand them, provided you brace the throat with negative energy, exotic matter arranged in just the right way. They didn't stop at a broad maybe. They calculated how the geometry would need to curve, how wide the passage would need to be, and where the supporting NEMs of negative energy would have to sit. They also described what such a doorway would look like to an ordinary eye, not a dark tunnel, but a floating, spherical opening, like a round window hung in space. Peer through, and you wouldn't see blackness. You'd see the scene on the other side, distorted as though through a lens, because light itself would take curved routes through the throat. If the mouths connected remote corners of the universe, distant galaxies might hang there, startlingly near, as if the night had folded to bring them close. Step through, and you'd arrive immediately, with no crushing, no violent shearing, no spaghettification. The trick would be to shape the throat so the strongest gravitational gradients never touch a traveler. In that sense, a traversable wormhole is less like a wild whirlpool and more like a carefully engineered harbor. The laws don't slam the door, they simply demand exact carpentry and rare materials. On the practical side, the same problem returns. We have no warehouse of negative energy and no reliable recipe for producing it in bulk. Quantum effects offer hints delicate as breath on glass, while the required scaffolding resembles a mountain. Even so, it matters that the math doesn't forbid the bridge. Physics has many ways to say no. Sometimes it draws a hard line. Other times it threads a needle and leaves a path so narrow you need the hands of a watchmaker. Wormholes belong to that second kind of permission. They're possible within strict boundaries, as long as the throat is held open by pressures that push outward where gravity pulls inward, and as long as the surrounding geometry is tuned to keep tidal forces small. Seen from that angle, gravity feels less like a bully and more like a careful bookkeeper. It keeps accounts balanced. It prefers stability and symmetry. It allows a shortcut only if the shortcut pays its dues with the right stresses in the right places. In engineering terms, a wormhole needs a keystone, something that carries tension rather than compression, a brace that resists the urge to fold. In space-time terms, that brace is negative energy density, regions where the energy tally dips below the usual floor, creating a sort of structural outward push. Do such regions exist on their own in the wild? Perhaps only in fleeting, microscopic ways. Some speculative pictures of the quantum world imagine space-time foaming at unimaginably tiny scales, little bubbles that wink in and out, like the fizz on the rim of a glass. If anything like a wormhole appears there, it would live fast and vanish, too small and too brief for a spaceship, too delicate even for a beam of light to test. In laboratories, our best attempts to steward negative energy are exercises in subtlety, ultra-clean vacuums, mirror-smooth plates brought unimaginably close, faint forces measured with instruments that can hear a feather fall. They prove a point. Nature can, in principle, make the right sign. It cannot, at present, make a doorway. Still, the picture that Morris and Thorne painted has a soothing kind of realism. It doesn't promise miracles. It asks for craftsmanship. A mouth on one side of space, a mouth on the other, and between them a throat shaped with grace so the ride feels like drifting down a slow river. Stand before that mouth, and the view is immediate. A patch of foreign sky framed in a round edge, near and far at once. The idea folds fancy into law, letting wonder and restraint share the same pillow. And we keep circling the crucial truth. Every traveler carries energy, even a single photon. Bring energy into the throat, and space-time listens. It curves in response. If the support is absent or too weak, the passage responds by tightening. The bridge fails because of the weight of the crossing. That's why any honest design for a usable wormhole leans so heavily on the elusive brace, building a cushion of outward push around the place where inpull is strongest. Some estimates for a person-friendly doorway are so large they read like parables, reminding us to keep our feet warm and our expectations measured. The gap between what theory allows and what tools can build is part of science's landscape, not a flaw. Today, we can coax whispers from the vacuum and image the shadow of a black hole across millions of light years. Tomorrow may do more. In the meantime, knowing the rules, leave room for a bridge under strict terms, offers a rare comfort. The universe isn't capricious, it's demanding. It doesn't hand out shortcuts, but it doesn't lock them in a safe marked never either. And if a shortcut is allowed at all, it must look like a careful arrangement rather than a miracle. That careful arrangement has a name drawn in late-night calculations by Kip Thorne and Michael Morris, the Morris-Thorne wormhole, a tender blueprint for a doorway that keeps faith with the rules. The picture is spare and elegant: two mouths, a short throat, and a promise that the ride can be kind if the geometry is tuned and an outward-leaning brace is supplied. The mouths are spherical openings in space-time, like round windows you can place where the equations permit, one hovering near the outer planets, the other glowing faintly in a distant spiral arm. Location isn't a moral question for space-time. It's a matter of design constraints met and conditions satisfied. Between the mouths rests the throat, the path that makes the shortcut a shortcut. Measured along the throat, the distance is short compared with the vast miles you'd cross if you took the long way through ordinary space. That brevity is the heart of the idea. Two far places press close by shape rather than speed. To keep the throat from tightening, its lining must be unusual. The equations ask for a gentle brace that pushes outward, where gravity leans inward, exotic matter with negative energy density, the same elusive ingredient that keeps returning like a necessary refrain. Without that brace, the passage closes as swiftly as a blink. With it, the throat can be held open like a lantern's wire frame, keeping soft paper from collapse. In this design, symmetry brings calm. The mouths appear spherical, simple and centered, while the throat curves between them like a smooth tube. Light can flow both ways. Matter, too. There is no one-way edge, no event horizon that traps what steps across. Even hesitation is allowed. You could begin to enter, feel uncertainty rise like a tide in the chest, and turn back the way you came. Nothing in the geometry punishes a change of heart. The interior tides, the differences in gravitational pull that stretch and squeeze, are kept small on purpose. Instead of being drawn thin like taffy near a black hole, a traveler would float as if in the middle of a quiet room. The plan is not for drama, but for gentleness. Approach one mouth, and the view on the far side grows clearer, as though you're walking toward a round window set in a wall of night. Stars that are actually far beyond far begin to feel local, their light magnified and distorted by the way geometry handles rays inside the throat. Step across the lip, and the change is sudden but not violent. There is no long tunnel, no cinema of streaking lines, only a clean jump in scenery, like turning a page. Behind you, the mouth frames the place you left, a small, precise portrait of home. The disorientation lasts a heartbeat, like waking from a nap in a train car and needing a second to remember where the journey was headed. The physics, tuned this way, invites you to relax your shoulders. Nothing about this picture cheats the deep structure of general relativity. It's built out of that structure. It also refuses to ignore the one hard cost. Exotic matter must be present, arranged with care around the throat to offset the urge to close. That remains the unsolved line in the ledger. The rest of the plan is tidy, plausible, and if the materials exist, ready to be engineered by patient minds and quiet machines. To ask where the brace might come from is to step from the large into the small. Classical physics offers no shelf where negative energy sits waiting. Every familiar field and particle we know carries a positive tally. Yet the quantum world keeps a soft door ajar. Empty space is not blank. It quivers with fluctuations, transient ripples that rise and fall so quickly they're almost a rumor. In that restless quiet, Hendrik Casimir found a practical whisper. Two metal plates brought very close together in vacuum restrict which fluctuations can dance in the narrow gap. Outside the plates, the vacuum is free to jitter in every allowed way. Between them, only certain notes are permitted. The imbalance nudges the plates toward each other with a tiny force that has been measured with instruments delicate enough to hear dust settle. The important part for our story is that the energy density between the plates comes out lower than the energy density outside. The gap holds a kind of less than usual, a local dip against the average. It isn't exotic matter in the full, defiant sense, but it points in the right direction. It shows that the universe can, under careful conditions, host regions where the energy book briefly reads below zero. Imagination takes that hint and stretches it to the scale of a doorway. If a civilization could manipulate quantum fields with precision, perhaps it could weave a sheath of negative energy around a throat, the way builders lay a tensioned cable to hold an arch. Maybe squeezed light states of the electromagnetic field or other tailored quantum configurations could deepen the dip. The ambition is soft-spoken, not boastful. Don't break physics, compose with it. Yet the gap between laboratory whispers and cathedral-sized structures remains large. The Casimir force is small. The amounts of negative energy we can coax are measured in units that feel like snowflakes. A human-sized passage would ask for a mountain's worth of careful arrangement. The difference in scale is the quiet wall we keep running into. Even so, the mere fact that negative energy density can exist in precise, local ways matters. It tells us the door is not stamped never in the language of general relativity. That hope brushes up against the energy conditions, principles that set boundaries on how matter and energy should behave if the geometry is to stay well behaved. The weak energy condition is the gentlest of these rules, and it says, in essence, that every observer should measure a non-negative energy density in the stuff they pass by. Ordinary fields obey this condition the way tides obey the moon. It's part of how we keep the world sensible. Quantum fields complicate the promise. Their fluctuations can produce brief pockets that dip below the usual floor, much like the space between Casimir plates. The weak energy condition isn't shattered in a wild way. It's violated in a controlled, local sense, fleeting and bounded. To hold a traversable wormhole steady, you would need those fleeting dips to be arranged so they don't just occur, they persist, and they pile up where the throat needs them. That ambition brushes against another kind of limit, quantum inequalities. These are like the fine print at the bottom of a generous offer. They set caps on how much negative energy you can have and how long you can keep it, linking depth to duration in a way that preserves the stability of the wider world. If the caps are tight enough, they rein in any attempt to scale a laboratory whisper into an interstellar doorway. If they're looser, they leave room for careful engineering to do slow, patient work. Across the community of thinkers who love these questions, the mood is steady rather than split. Some lean toward possibility, pointing to the ways quantum fields can be steered and shaped, to the techniques that already tame vacuum noise for precision measurements and communication. Others lean toward caution, noting that the same mathematics that gives small kindnesses often protects the larger order, that the universe seems to favor arrangements that keep mischief bounded. Everyone agrees on the essential point. Traversable wormholes demand negative energy in earnest, not as a brief cameo, but as a sustained role. Whether nature permits that much, that long, in that place, remains an open page. Return to the blueprint, then, and let the shape settle again in the mind's eye. Two mouths, round and quiet, a throat, short against the immensity it bridges. A lining that pushes outward like the memory of a breath. No horizons to trap a traveler, no tearing tides. Light moving in both directions, carrying images from there to here, and from here to there. If you stand before one mouth and watch, the far sky swells with detail. The faint dust of a nebula becomes textured. A distant galaxy's arms show spangles you'd never catch with a local telescope. Cross the lip, and the world answers immediately. Look back, and your old neighborhood sits framed like a photograph in a floating circle. The moment carries strangeness and honest disorientation, but the body remains untroubled. The power of the Morris Thorne picture is not that it promises a device we can build tomorrow. Its power is that it demonstrates how a doorway can be imagined without lying to the laws that keep the night stable. It reminds us that the universe is not hostile to the idea of bridges. It is merely particular about their carpentry. It asks for symmetry to quiet the tides, for a throat that stays generous, and for a lining whose sign is rare. It accepts visitors who turn back midway. It lets light go both ways. It is honest about what must be paid, and it refuses to let anyone step across unless the payment is made. From there, the conversation with quantum mechanics continues in a hush. Empty space is lively. Fluctuations wink and hum. Virtual pairs appear and part. In special arrangements, those fluctuations can be shepherded so that one region carries less bustle than its surroundings. The plates draw together. The meter needles twitch. You can almost hear the future engineers speaking softly to the vacuum, asking it to take on a particular shape, to hold that shape long enough for geometry to relax into a useful curve. Whether the vacuum agrees at macroscopic scales is unknown. Perhaps the universe has built-in safeguards, quantum inequalities that act like gentle chaperones at a midnight dance, making sure nothing too wild lasts too long. Perhaps not. For now, the debate lives where calm minds like to work, on the boundary between what is technically allowed and what is practically arrangeable. The weak energy condition yields in small pockets, but resists any sweeping surrender, while quantum inequalities sketch fences in the fog. Laboratory ingenuity nudges tiny forces forward each decade, and quantum fields in curved spacetime lay out ground rules for how negative energy may appear without letting causality fray or clocks go errant. Each proof, each measurement trims the hedges along the path, clearing the view even if the destination stays far. The feeling that remains is like standing on a night overlook with a folded map. You could cut a road through the mountains if you find the right pass, if you brace the slopes, if you respect the watershed. You don't have the machines yet, but the geology doesn't forbid it. The Morris Thorne blueprint is that sort of map, quiet, exact, marking the cliffs and noting where a bridge demands cables and the cables demand anchors we don't yet know how to forge. And so the picture waits, patient and precise. Two mouths, a short, horizon-free throat, gentle tides within, a lining that leans outward against gravity's inward habit. Quantum mechanics offers careful, local gifts, pockets of negative energy in principle, if not yet in bulk. Energy conditions write the house rules. Fluctuations find narrow, honest loopholes. Between those truths, a doorway sits on paper, biding time for a century that can weave its brace from the same cloth as the rest of the world. Between a map and a road lies the same condition: materials. If the universe can spare even a modest brace of negative energy, the blueprint becomes a build plan. Until a single theory can hold gravity and the quantum in the same gentle palm, we can't promise the cosmos can supply what a stable throat asks for. Still, the mind can idle there like a boat at anchor and sketch what building one would mean if exotic matter is real and gatherable in more than thimblefuls. First come two mouths, round openings in the fabric like quiet windows. The early universe may have winked out tiny skittish wormholes, if any survived. Finding one would be like catching a firefly in a fog. Then you'd coax it wider, feed the throat with negative energy, the way a lantern takes air while its ribs keep the shape. Push too hard, and geometry buckles into new instabilities. Too softly, and the passage purses and disappears. The art is balance, a smooth, even lining that urges outward without raising ripples, a layout that keeps tides gentle, a vigilance that holds the support in tune with the laws that keep the rest of the cosmos steady. When the passage holds steady at a useful size, the lining has to be tuned, not everywhere at once, but with the precision of a luthier tapping along a soundboard, adjusting the braces until the vibrations behave, The exotic matter must be spread, so its repulsive gravity exactly counters the inward lean. Any patchiness, any heavy spot or thin spot could set up waves and wrinkles, and those waves could tear the tunnel from the inside out. Stability, here, is less a wall and more a rhythm. Then comes placement. One mouth could stay home, maybe parked in a safe, quiet orbit where sunlight is polite and tides are mild. The other could be ferried away. Moving a mouth isn't like towing a buoy. The buoy floats in water. The mouth is a structure in space-time itself. Shifting it means changing the geometry around it, which costs energy. Nudge it gently and the throat may hum along without complaint. Yank it fast and the whole arrangement could sour and collapse. A ship might pull with patient thrust, decades of steady acceleration, then coast, then decelerate, as if leading a shy animal with a soft rope. The time scale would be measured in years or centuries, depending on the destination. Yet, once the distant mouth is settled, the shortcut becomes an everyday path. Step through here, arrive there. Crossing would take moments. The sky on the far side would look like an intimate secret. But motion has its own trick. Time keeps books differently for travelers who move and travelers who wait. If one mouth spends a season at high speed and returns to meet its twin, less time will have flowed for the one that raced. The two mouths will occupy the same place, yet be out of sync like clocks that lived different lives. That mismatch turns a bridge in space into a corridor in time. Imagine labeling the mouths A and B. You begin with both at rest, ticking together. You then accelerate B to a high fraction of light speed, carry it on a long arc, and bring it back to sit near A. Because of time dilation, B's own clock will have logged fewer years. Picture bringing B home after a grand loop. A has experienced 10 years. B, only 1. The mouths now share a location, but not a date. A is living in 2035. B is living in 2026. Walk into A in 2035, and you step out of B in 2026. You've moved through the same throat you trusted before, only now your exit lands in an earlier page of the calendar. From there, the loop writes itself. Stay near the returned mouth. Breathe the air of 2026. Wait a while, then stroll into A again when it shows the year you prefer. You've traced a path that bends back on your own history, what physicists call a closed time-like curve. Time-like because your motion never exceeds the cosmic speed limit. Closed because your route is a loop. It doesn't demand magic. It asks for careful acceleration, and the geometry a Morris Thorne throat already invites. The sensation of traveling such a path would be strange, but not violent. Step through one circle, and the world behind you displays the later date. Step out of the other, and the sky carries the earlier one. You could meet the place you left before it was ready for your return. You could carry a message upstream toward your own beginning. The equations do not flinch. They accept that space-time, if shaped just so, can reconnect a traveler with their past without breaking the rule against faster-than-light motion. Curved geometry does the work. In quieter language, space and time are threads of the same cloth. Move through one, you also move through the other. Most of the time, those threads lie flat enough that every traveler's path points from yesterday to tomorrow in a tidy way. But fold the cloth, stitch two patches together, and a path can circle back. The world line, the trace of a life in space-time, can become a loop you can walk. Such loops carry both tenderness and trouble. Tenderness, because the picture is coherent. and surprisingly gentle. Trouble, because the moment you permit a loop, stories with knots appear. Change the pace of one mouth and a garden of possibilities sprouts. A pilot could use the bridge for instant trips across light years while quietly offsetting birthdays. A patient could leave the hospital in spring and step out in winter by crossing the room. Families could build homes that look into different seasons through a round window, waving across mismatched calendars. The mind enjoys the warmth of these images. Yet the questions sharpen at the edges. If a corridor lets you reach back 9 years, what becomes of the things you might choose to do with that reach? How does a promise made in 2035 behave if you can step into 2026 and whisper in an earlier ear? What happens when a loop meets the fragile logic of cause and effect, where a single nudge can redirect whole branches of life? Those are not puzzles that drift away with sleep. They lean in, patient and insistent, asking for answers that soothe as much as they explain. Stand once more at the mouth. One side reads 2035, the other 2026. The path between is smooth and short, cushioned by an outward-leaning lining. Clocks disagree, yet the bridge holds, and your footprints can sketch a circle that crosses its own trace. The physics allows the loop in principle. The heart senses the snarl such permission can create. And there, right at that round threshold, the old riddles step forward, as familiar as a family story told at midnight. What if you meet the younger you and persuade them to turn away? What if a single act upstream unpicks the very thread that led you to the doorway? Picture the round mouth again, one side reading the later year, the other the earlier. You could step through and meet a version of your life that hasn't happened yet, or hasn't happened to you. Then the question leans close, warm and unsettling. What if you use that curve in time to tug on your own story? What if you stand beside your younger self and gently steer them away from the doorway? What if a small change upstream ripples forward and alters the home you came from? This is where the mind wanders into the old orchard of paradoxes. The most famous fruit there is, the grandfather paradox, simple enough to sketch in a whisper. Travel back far enough, and a tragic accident removes a grandparent before your parent is conceived. Without your parent, there is no you. Without you, there is no trip back. The loop eats its own tail. Cause and effect no longer line up like footprints in sand. They conflict, canceling each other the moment they're pressed. Physicists have tried to soften that knot without tearing the cloth. One gentle approach is the self-consistency idea associated with Igor Novikov. In this picture, the universe does not permit contradictions to blossom. You may reach back, but whatever you do has always been part of the story that led you to reach back. Try to fire the gun and it jams. Try a different route and a stranger's clumsy umbrella spoils the plan. Try kindness and find that kindness was already woven into the road you remember. History stays consistent, not by locking your hands, but by making every allowed action join the same tapestry. It is tidy, and it keeps the logic of events from splitting, yet it carries the taste of predestination that some find hard to swallow. If your hand was always going to slip, did you truly choose? Another path takes courage from the quantum and spreads the burden across many branches. In the many worlds view, every meaningful fork in outcomes blooms into parallel threads. Change the past in one branch, save or harm, speak or stay silent, and you don't erase yourself in the branch that launched you. You simply step into a neighboring story where the upstream event differs. The contradiction dissolves because cause and effect never fight in the same line. They belong to different lines. The price is abundance, a universe that continually buds new realities. For some, that extravagance is too much ornament. For others, it is an honest accounting of quantum possibility that cleans up paradox with a single, sweeping gesture. A third mood is sterner and more protective. Perhaps time travel to the past is never truly available, not because imagination lacks nerve, but because nature keeps a quiet bouncer at the door. Stephen Hawking gave that intuition a name, chronology, as protection, the idea that whenever a machine tries to fold space-time into a loop that meets its own tail, something physical intervenes. The wormhole shivers, amplifies tiny disturbances, and collapses. The required stress blows past safe limits. A subtle instability grows into a break. Nothing supernatural, just the world defending the coherence of cause and effect, the way a healthy body defends against a fever. Quantum physics gives that defense an interesting voice. When you model a time-looping passage, even with modest ingredients, a single photon wandering through the mouth, circling back and meeting its younger self, the calculation can turn into a hall of mirrors. The future photon nudges the past photon, which changes the later nudge, which changes the earlier path again. The pieces feeding each other, like microphone and speaker in a tight room. In many setups, the energy density near the throat spikes higher and higher until the math flags a singularity or an unbounded growth. That runaway could wreck the machine before paradox has a chance to hatch. It's a bit like the universe clearing its throat loudly enough to end the conversation. Not everyone is convinced that the throat must always tear. The quantum rules we trust are best understood on flat stages, while wormholes demand curved ones. Our union of the two quantum fields on curved spacetime is powerful, but not yet the final word. Without a complete theory that marries gravity and the quantum, predictions near such extreme geometries live in a twilight of likely and maybe. Some researchers even find comfort in the thought that quantum mechanics might enforce self-consistency by itself, selecting only those histories that stitch without contradiction. In that style of physics, the future's gentle touch can guide the past in ways that never break the logic of events, a kind of echo that arranges itself into harmony. There are schemes that try to write this harmony in equations. They trade open paradox for fixed points among all the possible interactions between versions of a system. At different times, only those with consistent outcomes survive. Nothing like a policeman with a whistle, more like a river seeking the one channel that lets it flow without backing up. It's an appealing melody if you like your puzzles solved softly. It also reminds us how far our intuition, trained on clocks and rails, has to stretch when time itself becomes part of the architecture we can bend. Step back from the theoretical glow and the bedtime feeling returns. A wormhole tuned for travel already asks for negative energy, arranged like a careful brace. Turn that brace into a time machine by moving a mouth, and the stakes rise. The same quantum effects that whisper maybe to exotic matter whisper warnings about feedback and runaway loops. The same general relativity that allows closed time-like curves does not promise they will be easy to tend. Between allowed in principle and stable in practice lies a countryside of conditions, limits, and delicate balances. If the universe does hide a safeguard, it may look less like a hard fence and more like a set of quiet inequalities. caps on how much negative energy can exist and how long it can be kept in one place, relationships that tie depth to duration so tightly that macroscopic loops never mature. Those constraints would let the small, local oddities of the quantum world breathe while protecting the grand, global order that keeps moons circling and hearts beating in a regular time. And still, there's room enough in careful minds and careful math to keep the door cracked. The equations of relativity do not storm out when we mention loops. They nod with caveats. Quantum theory doesn't shrug. It raises a skeptical eyebrow and asks for a better map. Somewhere beyond those gestures waits the marriage quantum gravity that can answer whether a traveler's loop is a real road or only a mirage that vanishes when you get close. So the questions rest beside the pillow. If you could step back 9 years, could you truly change the thing that led you there? Or would the world guide your hand away from contradiction? If branches are real, how many stories does kindness write? And how many does caution erase? If protection is nature's habit, how does it whisper, "Not this way," without ever raising its voice? The night holds those riddles gently, and while they rest, another tenderness rises, the thought that perhaps the universe has been building or erasing such doorways on its own, long before hands and instruments could even dream of shaping one. Some riddles sit so deep in physics that they feel like wells with their own weather. Whether nature makes wormholes on its own is one of those. We've been picturing careful blueprints and patient engineering, but the universe has been at work far longer than our instruments have. If there are doorways, maybe some were born in the first wild minutes after everything began, when space wasn't yet smooth, when energy foamed and flickered, when distance and time were still learning how to behave. In that newborn turbulence, spacetime may have grown tiny tunnels the way frost grows filigree on glass brief, delicate connections no wider than the smallest meaningful scale we know how to name. Physicists call that scale the Planck length, and the world down there doesn't look like a calm sheet at all. It looks like sea foam, bubbles budding and popping so quickly, the words before and after feel too slow. A primordial wormhole in that regime would be smaller than an atom by an absurd margin, flickering in and out like a hiccup of geometry. Most would die as fast as they were born, swallowed by the same restlessness that made them. And yet, there's a gentle perhaps that lingers. The early universe seems to have rushed through a dizzying growth spurt called inflation, an expansion so rapid it could stretch microscopic ripples into macroscopic features. If a few of those baby tunnels were caught in the swell, they might have been pulled to sizes we can imagine, sustained not by miracle, but by timing. If any survived, they'd be rare, lonely pearls, lost in a dark ocean, but not impossibly small. They would be big enough to leave faint fingerprints on the light passing by. Finding such a thing would ask for patience and an eye for subtleties. Black holes announce themselves with drama, stars slingshotting around invisible anchors, gas heating to a bright scream, space-time itself ringing when two collide. Wormholes, especially quiet ones, might leave only a soft signature. One clue could be lensing the way mass bends light. A mouth could act like a round lens in the sky, distorting the shapes behind it. But the cosmos is already crowded with lenses, galaxies that smear background arcs into crescents, clusters that paint halos, stray compact objects that briefly magnify a star and then let it fade back. To pick out a wormhole among these would be like hearing a flute in a busy orchestra and naming the brand by tone alone. Even so, A wormhole might bend light a little differently, especially if its lining involves stresses unlike ordinary matter. Instead of gathering rays the way mass normally does, some configurations could scatter or defocus them in telltale patterns, or add unusual time delays to flickers passing near the mouth. In fields full of variable stars and flickering quasars, astronomers already watch for microlensing, tiny temporary brightenings when a compact object wanders in front of a distant source. A wormhole could leave an asymmetric, multi-peaked light curve, or a color-indifferent magnification that doesn't quite match the curves we expect from stars, black holes, or rogue planets. The difference might be small, but small differences are astronomy's bread and butter. Another path is to listen for the fabric itself. If a wormhole sits in a busy neighborhood, say, near the crowded heart of a galaxy, its presence might slightly irritate the paths of nearby stars. Astronomers who track orbits with exquisite care, the way they trace the stars looping the dark mass at our own galactic center, could notice motions that don't square with a single compact object. A star's ellipse might precess in a way that refuses the usual explanations, or a cluster of orbits might share a suspicious twist, as if tugged by a hidden passage rather than a hidden lump. The throat's lining, if it truly leans outward with negative energy, could also whisper in radiation. Exotic stresses might stir fields into odd behavior, kindling emissions that don't fit the typical script of hot gas and magnetic tantrums. A point in the sky could flicker in high-energy photons for reasons that have nothing to do with accretion or jets. We already keep catalogs of strange transients, bright happenings that appear and vanish like fireflies, fast radio bursts, gamma-ray flashes, optical outbursts that last an evening and never repeat. Most will have familiar parents once we learn their language. A few might remain stubbornly unclaimed, tempting us to widen our list of suspects. There's also the old rumor that some black holes might be doorways wearing a mask. Inside their horizons, where our current equations shrug, a wormhole could replace the singular point we write down out of ignorance. If that's true, then every black hole is a one-way street. You can step in and follow the river wherever it goes, but you can't send a postcard back. The horizon is a strict gate. Information doesn't return the way we'd like. From far away, the difference between hole to elsewhere and hole to nowhere may be impossible to see because the horizon keeps secrets well. We can't fly a probe across that line and expect a report. Crossing is the end of conversation. Still, the notion changes the tint of the night. It means the universe could be thick with silent corridors, each hidden behind a dark disk where light fails. Trillions of doorways, most in galaxies' hearts, some wandering like embers through the halos, linking remote provinces or even bridging to realms with different rules. It's a romantic thought that must sit beside a sober one. We might never know for sure by looking from the outside. A one-way gate is a kind of promise we can hear but not verify. If nature prefers two-way passages, we'd need a different sign. Matter might fall into one mouth and every so often spill from the other. Not a polite stream, more like a cough brief, bright, strangely flavored. A mouth in deep space could burp out particles that don't fit any local weather. A plume of high-energy neutrinos without a supernova to blame. A burst of gamma rays with no collapsing star. A knot of plasma racing away from nothing. The physics of the throat would decide the recipe, how much arrives, at what speed, and how tangled the field lines get on the way out. For us, the task would be to sort these spurts from the many known fireworks of the sky, to say, this, perhaps, is a mouth exhaling. Even the quietest hint would demand a chorus of instruments. Lenses and surveys that watch millions of stars at once, radio dishes that listen for sharp, inexplicable ticks, X-ray eyes that notice when nothing visible should be hot but is, neutrino detectors that feel a passing shiver in the deep, gravitational wave observatories that can tell when the fabric itself has been plucked. Each offers a piece of a puzzle that, if arranged just so, could outline a door. If these doorways were born in the first seconds, some might carry the imprint of that age-subtle correlations between where they prefer to sit and the web of galaxies spun from the same initial seeds. Others, if tied to black hole interiors, might cluster where black holes do, keeping the company of stars, dust, and dark matter in galactic centers. Either way, we're only now acquiring the patience and sensitivity to notice anything so shy. The first hints would likely be statistical odd curves, skewed patterns arriving long before anyone points and says, there. And beneath the hunt lives a simple comfort. Whether wormholes are rare relics, common features, or fantasies dressed in math, the search itself deepens our hearing. We learn to read the small print of gravity's lensing, to follow stellar footsteps more closely, to tell one flavor of flash from another across the spectrum. We train our attention on the subtle and the brief, and the universe, which is very good at both, rewards us with unrelated wonders while we wait. There is a kind of quiet symmetry in that. Doorways may exist, or not. The act of looking patient, curious, precise still opens something. And if a tunnel ever does cough or glimmer in exactly the right way, it will be because we taught ourselves to notice, to hold our breath at the right moment, and to let a tiny, strange pattern mean more than it did the night before. Telescopes already keep vigil for brief events that flare and fade before a human heartbeat has counted to 10. Somewhere in that gallery of transience, a wormhole might make its presence known not with thunder, but with a pattern that refuses ordinary labels. So far, nothing has stepped forward and announced itself. The search is young, the sky is large, and our tools grow steadier hands each year. As sensitivity climbs and our models learn new dialects of starlight, a door that once looked like noise could sharpen into a candidate, and a candidate into a clue. Another thread has drawn theorists to their desks late at night. A quiet kinship between wormholes and quantum entanglement. Entanglement is the way two particles can share a single description, so that a measurement here lines up with a measurement there, even if there is on the far side of a galaxy. No message races between them. The match isn't a secret telegram, it's a built-in correlation, part of the state itself. Einstein teased it as spooky because it unsettles the tidy idea that influence must march at light's pace. Experiments, repeated and refined, have watched those correlations behave exactly as the quantum rules say they should. The spookiness is real. The speed violation is not. A bold proposal wrapped these two notions together with a neat bow. ER equals EPR. ER evokes the Einstein-Rosen bridge, the mathematical wormhole of early relativity. EPR recalls the Einstein-Podolsky-Rosen paper that set the entanglement puzzle on the table. The slogan says, gently, that the correlation between entangled partners can be pictured as a microscopic bridge, not a tunnel you could sail through. No cargo, no messages, just a tiny stitch in spacetime's cloth. Look from far away and the fabric seems smooth. Zoom down to the tiniest threads and it looks like a web of connections, each entangled pair held together by an invisible tie. In that view, spacetime isn't something on which quantum fields sit. Spacetime is something that quantum entanglement helps to weave. If the cloth is woven this way, wormholes stop being rare ornaments and become part of the loom. Every time two systems become entangled, you've added a stitch. Most stitches are unimaginably small and entirely useless for travel, but their existence hints that bridges are not alien to the universe, they are its grammar. That shift in intuition reaches into another long-running riddle. What happens to information that falls into a black hole? Quantum theory hates losing information. General relativity seems to allow it to vanish behind a horizon forever. If a black hole shares deep entanglement with the wider world, the lost information could be preserved in those correlations, flowing not as letters through a tunnel, but as structure in the joint quantum state. No single experiment has settled this, but the direction is promising. Instead of being a shredder, a black hole becomes a knot whose pattern can be preserved, read indirectly in the fine print of entanglement. The same web stretches farther than one universe in some imaginations. If reality contains more than one cosmic bubble, if inflation never truly ends, budding new regions endlessly, then there are other expanses with their own settings for the dials of physics. Gravity might grip more tightly there, light might tally seconds differently, chemistry might sing in unfamiliar keys. In such a landscape, a wormhole could be more than a neighborhood shortcut. It could be the seam where two bubbles touch. Step through, and everything familiar would tilt. Different stars, different matter, maybe no atoms at all arranged the way we know. There are bolder whispers. A black hole here could appear as a white hole there, a place that only exhales so that what falls inward on our side spills outward on the other, like a fountain. The picture is delicate. It depends on details we don't yet command, how horizons encode information, what quantum geometry does in the places where classical geometry would draw a singular point, which states are allowed and which are quietly forbidden. It is also, despite the daring, a natural extension of the same mathematics that blessed wormholes in the first place. If geometry can connect distant points within one spacetime, it has no principled objection to connecting different spacetimes. The complaint comes later, from stability and materials. Keeping such a bridge open without tearing either world may be harder than just writing the tunnel down in symbols. Even if the multiverse is only a scaffold for thought, the exercise is valuable. It teaches the eye to separate what the equations allow from what they encourage, what a picture promises from what a construction can bear. It also adds a surprising gentleness to the idea of elsewhere. The bridge isn't fireworks. It's a quiet curve held up by careful stresses. If those stresses can be supplied in some corner of nature or by hands we don't yet have, then crossing from one rule book to another is at least a coherent sentence, not nonsense written in chalk. Meanwhile, the work at human scale continues. Observatories watch for transients that refuse old names. Interferometers listen for the faintest quiver of space-time, in case a passing bridge leaves a signature tremble. Arrays tune themselves to the quick clicks of radio and the long sighs of infrared, ready to catch a burst that looks like matter appearing where no nursery can account for it. The catalogs fill with candidates. Most resolve into known families: supernovae, flares, mergers, lenses, jets. A few linger on the edge of understanding and invite us to build better questions. What returns through all of this is the same melody: connection. Entanglement connects systems so intimately that distance looks like a courtesy, not a barrier. Wormholes connect regions by bending geometry so that far becomes adjacent. Black holes and the spaces around them connect quantum rules to gravitational ones, forcing each to learn the other's grammar. Whether or not a traveler ever steps through a round, patient mouth, the universe already acts as if stitching is its favorite art. On some night to come, a light curve might arrive with just the wrong shape to be ordinary. A lens might bend a background picture in a way no galaxy cluster could. A burst might carry energies and timings that speak of matter emerging from a region that has no factory. Or entanglement experiments stretched to cosmic scales might reveal patterns that only a woven geometry can explain. Each of those would be a small knock on a door we've been half dreaming, half deriving. Somewhere between caution and wonder, the story holds together. The bridges we draw on paper behave like honest citizens of the laws we trust. The quantum stitches we test in labs speak a language that could, in principle, scale. The black hole riddles may take their answers from the same cloth. If the picture is right, then the cosmos is more braided than we guessed. Threads within threads, loops within loops, countless tiny ties keeping the whole from unraveling. And if the picture is wrong in some important way, the corrections will be beautiful, because they'll teach us how space-time and information truly share the load. Either path is a kind of kindness. We learn the world's preferences, and the world rewards the attention. In the hush that follows, a sentence takes shape, simple and steady, pointing where the dream grows widest. Not just shortcuts through space, not just time machines, but bridges between entire realities. Bridges between entire realities sound like lullabies sung by math, but the moment hands reach for tools, the air gets thin. If a traversable wormhole is even allowed, turning permission into construction stacks challenge upon challenge, each one steep enough to humble any civilization. The first hill is the material itself. A steady throat needs an outward-leaning brace, negative energy arranged with care. Nothing we have ever held behaves that way, in bulk. No sealed vial of exotic matter sits in a lab fridge. No production recipe exists. Even if nature permits it, the amounts required for a doorway big enough for a person would likely rival the mass energy of a world, perhaps a star, gathered and tuned to a whisper's precision. That's not just a tall order, it's a mountain range. Then comes precision, the sort that treats space-time like a finely carved instrument. The brace can't be piled up like sandbags. It must be shaped and spread so each point along the throat feels just the right outward nudge. Too much in a patch, and ripples grow. Too little, and the walls lean inward, keeping tidal forces gentle, while preventing collapse calls for feedback. As delicate as the way a musician adjusts finger pressure to keep a chord in tune. This isn't merely technology, it's choreography with gravity. Construction itself is its own riddle. If the universe sprinkles tiny, short-lived tunnels in its quantum foam, one path is to find a survivor and nurse it larger. Feed the throat, negative energy. Stitch the lining, widen the mouth. That asks for control over geometry at scales where space is froth. The other path is to carve a tunnel from scratch by focusing vast energy into a region until the fabric curves, into a bridge. In sketches, that's a line or two. In practice, the required energy looks like a ledger written in starlight. Even after a passage is coaxed open, time becomes an adversary. A stable throat today can be an unstable throat tomorrow if the lining drifts, a cosmic ray storms through, or a distant mass shifts the local field in some small, cumulative way. Monitoring might need to be continuous. Corrections might need to be made faster than a heartbeat forever. Maintenance becomes a promise carved into the design. And safety is the long shadow. A wormhole is not a tunnel cut through rock. It's structure cut through the rules that structure everything else. What does the neighborhood feel? Gentle or jittery? Does the lining hum at frequencies that shower nearby space with radiation? Do orbiting bodies subtly drift over centuries? Do magnetic fields twist in ways star systems don't like? Before anyone steps through, the quiet must be measured and the risks weighed with the seriousness reserved for oceans and weather, not just roads. Even wrapped in caveats, imaginations that love problem-solving keep going. Picture a culture that has learned to sculpt fields as easily as we sculpt clay, that can borrow negative energy from quantum subtleties and return it on time, that can read the geometry of a room the way a conductor reads a score. One working passage would change the texture of life. Scales would shrink, a planet to a planet in the span of a breath, a library, a galaxy away as reachable as the shelf across the room. Trade would be less about goods than ideas. Disasters would be answered with evacuation routes, not prayer and luck. A net of doors could turn a species parochial by choice, not by constraint. Even the act of building such a network would teach responsibility. Every mouth needs tending. Every corridor touches many homes. Set beside Wormholes is another famous sketch in the Atlas of Faster-than-Light Dreams, the Alcubierre warp. It does not shove a ship through space. It reshapes space around the ship. Compress a little in front, expand a little behind, and the bubble that carries you can outrun a light beam measured by a distant clock, while inside the bubble you float in ordinary, local calm. The trick stays loyal to relativity's embargo on superluminal motion. Nothing inside exceeds light speed relative to its bubble. The bubble moves. You are carried. The price list looks familiar. The bubble's leading edge calls for negative energy, the same sign problem that haunts wormholes. Early sums for the energy bill were comically huge, larger than the inventory of the visible universe. Later, cleverness shaved many zeros, but the bill still towers above any power plant we can imagine. Stability is a second worry. Some models hint that bubbles might be born unstable, collapsing before they can be steered. Others suggest the ride could accumulate dangerous quanta at the front, releasing a harsh flash when the bubble stops, an arrival that glows more like a weapon than a welcome. None of these are verdicts. They are warnings written in pencil. Yet, the sketch persists because it teaches a helpful lesson. Faster-than-light travel is not forbidden in the bluntest sense. It's fenced by materials, balances, and boundary conditions that we don't yet command. Variations flutter at the edges, ships that hop from one small warp pocket to the next, instead of sustaining a grand bubble. Designs that borrow curvature from neighborhoods already warped, like the skirts of neutron stars or the deep wells around black holes. Ideas that swap energy-hungry perfection for messy, workable, good enough. Each variant reduces one pain and inflames another. All of them share a moral with wormholes. The laws are tolerant but picky, and the pickiness centers on negative energy and fine control. Perspective helps. The road from hot air balloons to quiet jets took centuries, not because the air changed, but because understanding and craft did. Here, the medium is space-time, and the craft is geometry disciplined by quantum rules. The gaps feel larger because the material is stranger. That doesn't make the effort unkind, it makes it slower and more honest. Even if the doors we picture stay on paper, the pursuit rearranges the way we listen to the sky. Surveys that watch for odd lensing, instruments that weigh tiny forces between plates, detectors that hear the thrum of space-time when heavy things collide. These are not side quests. They train our hands. They let us test the edges where classical smoothness gives way to quantum thread. They make us better caretakers of the truths we already hold. Think again about what a network would mean if, one distant century, someone finally wove a throat and taught it to hold. The map of danger would change. Supernova imminent. Step the town through. A homeworld grows restless. Share the load among many valleys of stars. Cultures could braid, not by conquest but by visits that respect the time of both sides. The responsibility would be enormous. Corridors bind fates, and knots, once tied, are hard to undo. But responsibility is what adults do with power. It's how bridges become part of landscape rather than scars upon it. Across the room, the Alcubierre bubble sits like a sibling dream, a way to go fast by making fast into a property of space instead of motion. It is generous in the same way and strict in the same places. It offers a complement to wormholes, less a door, more a moving room. If wormholes are tunnels fixed between places, warp is a conveyor that brings places to a ship and carries them past. Both ask for the same strange fuel. Both punish sloppiness. Both reward respect. None of this promises arrival. It promises a direction and a mood. The direction points toward deeper marriages between gravity and the quantum, between engineering and ethics. The mood keeps the voice low because night is for resting as much as for wondering. Somewhere out there, stars follow their old paths, galaxies drift like slow rivers, and the fabric that holds them is quiet and reliable. If, someday, a doorway opens or a bubble hums, it will be because that same fabric agreed to a new kind of fold, one earned stitch at a time, lit by patience rather than fire. Out in the dark, a quiet question keeps tapping. If the universe is so old and so generous with stars, where is everyone? We've listened for decades, ears pressed to the cosmic doorframe, and heard only the wind. No radio greetings, no engineered shadows swallowing starlight, no careful visitors knocking on our atmosphere. The Milky Way alone holds hundreds of billions of suns, many cradle planets. Some of those worlds sit in temperate light, where water could linger and chemistry could practice being brave. If even a modest fraction learned to think with tools, the night should hum with company. And yet, we drift in a stillness that feels both tender and strange. One soft answer leans on bridges. If passageways are real, if a patient species can brace a wormhole's throat and keep it open, then the roots that matter might be the ones that don't glitter for distant eyes. You don't send radio waves when you can step across a room. You don't build continent-sized power plants if a doorway renders distance unimportant. A culture fluent in wormholes would not light up our surveys with grand constructions or chatty beacons. It would travel by absence, by private corridors stitched from geometry itself. They could be everywhere and nowhere, crossing without wake, preferring quiet hallways to noisy roads. That reading of the silence turns the mirror back on us. Perhaps we live before doors. Our probes hum around nearby worlds. Our dreams stretch toward Mars. Our fastest emissaries, flung decades ago, are still within the sun's long reach. If geometry one day agrees to a new fold, the scale of our lives will change in an instant. Whole catalogs of worlds would move from myth to map. For now, we are local creatures, clever and grounded, waving into an emptiness that might simply be sidestepping our kind of wave. Of course, there is the sterner possibility that keeps our curiosity honest. Perhaps traversable wormholes are forbidden in the large, not by etiquette, but by law. If nature protects chronology tightly enough, if quantum inequalities keep negative energy on a short leash, then no civilization, however patient, can pin a throat open for travelers. In that world, the quiet remains a riddle, and the Fermi paradox keeps its bite. We would be back to other explanations: rare life, rare intelligence, rare survival, or a cosmic zoo where the glass is one way and we are the exhibit that isn't told. While the sky stays shy, stories do the generous work of keeping wonder fluent. Wormholes have wandered across pages and screens for years, sometimes as simple plot keys, sometimes as thoughtful portraits shaped by real equations. One of the most careful depictions arrived in Interstellar, where physicist Kip Thorne shepherded the math and artists translated geometry into images. On approach, the thing looks like a dark sphere that reveals another sky within its curved mirror, stars from elsewhere swelling in clarity as the ship draws near, light bent in faithful arcs by spacetime's lens. It is haunting not because it is flashy, but because it's honest, the kind of beauty that comes from letting the rules speak. Other worlds of fiction play freer jazz. Star Trek slips through a stable corridor near a busy station. Stargate clicks open round thresholds with a satisfying rush. Countless novels treat wormholes as highways with mile markers and rest stops. The physics is often softened, the need for exotic matter politely ignored, but the service they provide is real. They give a broad audience the shape of the idea that space can be folded, that time can be slippery, that journeys can be reimagined as geometry rather than speed. Many working scientists were first nudged along this path by a tale told well at the right age. Sometimes science begins as a bedtime story that refuses to fade in the morning. Behind the stories, the hard questions cluster where two great pillars of understanding still look at each other like strangers who know they're related. General relativity explains the large, planets in their lanes, clocks running slow in deep gravity, the way mass tells geometry how to curve. Quantum mechanics explains the small, particles as waves, uncertainty as a basic kindness, entanglement as a quiet stitch between distant systems. Each is a masterpiece. Together, as they stand today, they bicker, especially in the loud places inside black holes, at the first light of the universe, in throats we'd like to hold open. Bringing them into one conversation is the project called quantum gravity, and many languages are being tried. String theory imagines the fundamental notes as tiny loops and lines whose vibrations play out as particles, with extra dimensions and brains offering new stages for geometry to dance. In those scores, wormholes can appear naturally, sewn by strings into the fabric as permitted rifts. Loop quantum gravity takes a different approach, quantizing space itself, so that area and volume come in discrete quanta. The smooth field becomes a weave of finite threads, and a tunnel becomes a particular pattern in that weave. The holographic principle turns perspective inside out. A volume of space may be fully described by data living on a boundary, like a three-dimensional world written on a two-dimensional screen. There, too, bridges and entanglement meet, suggesting that the depth we move through might be an emergent story told by relationships on a thin edge. None of these frameworks is settled. All have gifted insights and carried puzzles in return. What they share is a habit of blurring what once felt separate. Space becomes less like a background and more like a product of quantum relationships. Information stops being an afterthought and becomes central to gravity's accounting. It is exactly the kind of shift that makes wormholes feel less like exotic exceptions and more like particular arrangements of the same threads that already bind everything. Even without final answers, this fieldwork changes how we listen. We refine tests for lensing that could betray a peculiar mouth. We model the dance of stars near galactic centers to catch anomalies a simple mass can't explain. We push Casimir measurements in quantum optics to see how far negative energy can be coaxed without breaking anything else. We sharpen gravitational wave hearing in case a passage groans when nearby masses move. Each advance, even when it fails to find a door, polishes our understanding of the walls and sometimes reveals unimagined windows. Culture and calculation aren't in different rooms here. The most rigorous papers can be sparked by a question planted by a novel. A film guided by real equations can make a generation more receptive to the idea that geometry is malleable and time is elastic. That exchange doesn't trivialize the science. It keeps it human, grounded in the same urge that sent hands to clay and minds to numbers. Wormholes sit exactly where imagination and discipline shake hands, one suggests. The other checks, both adjust. So the picture that's been forming in this long, slow telling holds steady for a moment more. Silence might be the blush of civilizations that travel by private corridors. Silence might be the warning that no such corridors can be held. Stories keep the contour of the idea clear in the public mind. Mathematics keeps pruning what isn't allowed and nourishing what might be. Quantum gravity waits like a forthcoming chapter that someone else is writing in another room, and the night itself stays kind, patient with our questions. Somewhere within that patience lives the most childlike curiosity of all, folded neatly into the grown-up rigor. Whether a wormhole can be seen and named by instruments we build with careful hands, whether one can be made at all, whether the gentle bridges we've drawn on paper can ever leave the page. The answer depends on what nature permits, on how clever a species can become without losing its humility, and on how closely we can listen to a universe that prefers to speak in subtle tones rather than shouts. One question glows, like a small lantern at the edge of sleep. Will we ever truly see a wormhole? If nature makes them, could we learn to recognize their signatures in the noise of the sky? And if nature does not, could patient hands and deeper understanding one day stitch one together anyway? The honest answer depends on a braid of chances, cosmic history, subtle clues, and how deftly we learn to listen. If the first minutes after the beginning seeded tiny tunnels and a few survived the universe's long weather, Faint evidence might already be drifting toward our telescopes. A mouth can bend passing starlight in ways that mimic other lenses, but not perfectly. With surveys that watch millions of sources at once and models that predict how an ordinary lens should behave, astronomers can sift for the small misfits, the light curves with an extra ripple, the distortions whose symmetry is off by a hair. A single event won't be enough. Patterns will matter more than trophies. Meanwhile, the new ears of astronomy, gravitational wave detectors, are teaching us to feel the fabric directly. If a bridge vibrates under the passage of nearby masses, or if its geometry alters the ring of merging objects, the resulting waves might carry an accent we've never heard. No one has cataloged such an accent yet, but the instruments are improving. The silence will be measured, not assumed. There's a more intimate possibility hiding in plain sight. If the deep connection between entanglement and microscopic bridges is even roughly right, then tiny, non-traversable wormholes accompany the quantum correlations we already craft in laboratories. They're not doors we can use, but they are bonds we can study. As we sharpen tools that prepare and probe entangled states over longer distances and longer times, we may find ways to test how geometry and information intertwine glimpses of stitching rather than the cloth it supports. The payoff wouldn't be a ticket to another star. It would be something subtler and, in its way, just as grand. A clearer map of how space itself is woven. If a civilization ever learned to build a macroscopic throat, the evidence would be as direct as a warm wind from an open door. But that image lives far down the timeline. The materials list is unforgiving. The precision demanded is almost ascetic. For now, wormholes remain faithful residents of the page, solutions that the laws permit, not yet residents of the sky we can point to. That they are permitted at all is its own kind of wonder, a reminder that physical law can be stricter than our dreams and still more surprising. Whether the cosmos hosts bridges or not, they've already bent our thinking in fruitful ways. They press us to respect the limits of cause and order while still peeking over the fence. They coax new mathematics into existence, force old ideas to admit their blind spots, and encourage crosstalk between fields that used to ignore one another. The same work that worries over exotic matter also refines our picture of black holes. The same thought experiments that toy with loops in time deepen our sense of how quantum information behaves and where it goes. Out of this ferment came bold proposals and protective cautions. The idea that entanglement and bridges might be two dialects of one language. The suspicion that nature safeguards history with quiet constraints. The insight that space-time could be less like a smooth sheet and more like an emergent net of relationships. These are not empty ornaments for chalkboards. If bridges can exist in any durable form, then the universe is stitched more tightly than distance suggests. Remote regions might be neighbors by another measure. Separate moments might be accessible in careful, bounded ways. The phrase elsewhere might need footnotes. If bridges cannot exist beyond the evanescent flicker of the quantum, that verdict is just as instructive. It tells us that causality has teeth, that negative energy is domesticated only briefly and in small corrals, that the great river of time keeps its one-way current outside the tiniest eddies. Either way, the pursuit clarifies the rules of the house we live in. Under the dome of night, another, older dream returns, the one about crossing the gulf to stand on other shores. We have always looked up and felt the ache of distance. Proxima Centauri is 4+ years for light, and for us, lifetimes. Our craft nibble at the edges of the solar system. Our lives end before the postcards reach their destinations. A traversable wormhole, if such a thing can be coaxed into being, would dissolve that ache the way a key dissolves a locked door. A step and a foreign sun warms your face. Whole libraries of weather, geology, and life, if life is there to greet us, would open all at once. The scale of human culture would pivot from islands to archipelagos. The universe may never grant that permission. Exotic matter might remain a rumor at scales that matter, and any attempt to stabilize a throat may invite the quiet enforcers of chronology to close it. If that is our fate, the dream still earns its keep. It pries at assumptions, provokes better experiments, and sharpens our standards for evidence. It reminds us that the cosmos is not obligated to be convenient, only consistent, and that consistency is its own form of generosity. Asking, what if, is how we find the places where what is has room to grow. At its deepest, the idea of a wormhole is a lesson about reality's flexibility. Space stops being the fixed hallway down which events march. Time stops being merely a metronome. Fold the hallway, and rooms that seem distant can share a wall. Twist the metronome, and rhythms can almost meet themselves. Even as metaphors, those images unsettle and invite. What do we mean by distance? If adjacency is negotiable, how do we think about identity and memory if a careful path could take us near our own beginnings? These aren't only physicists' puzzles, they're human ones, rubbing against questions of choice, fate, and how stories hold together. The search does not stand still. Gravitational wave observatories keep lowering their floors, hearing fainter tremors from farther away. Telescopes map the sky in deeper layers, building time series portraits of millions of changing points. Quantum devices become quieter, cleaner, more willful, letting us set up states that would have sounded like jokes a generation ago. Alongside, theory tightens bolts and adds braces, finding where the math contradicts itself and where it yields to a softer, truer form. Each step answers a specific question and almost always reveals 3 better ones. If bridges do exist on a useful scale, patience and craft will find them. If they do not, patience and craft will explain why. Either path is a kind of victory. Clarity is not as flashy as shortcuts, but history shows it builds better roads. The very act of looking hard for something unlikely breeds instruments and methods that end up serving other, nearer aims. Diagnosing the living Earth, protecting satellites, guiding ships, testing materials, illuminating the way light and matter talk to each other when they think no one is listening. Behind all that work stands a very old impulse. What if has led us from fire to number, from sail to circuit, from myths painted on ceilings to maps etched in radio light. What if space is not a barrier, but a shape, is simply the latest, widest version? Whether we meet another intelligence through a round, patient mouth or never meet one at all, the question turns us outward and holds us together. It puts our brief lives in conversation with a very large, very calm world that does not mind being asked the same thing 1,000 ways. If we last, if we keep learning without letting our reach outrun our care, there will be choices to make. Stay local and cultivate depth, or stretch a net of attention across unimaginable distances. Travel by messages or by visits. Treat the sky as ceiling or as porch. Bridges would make the porch larger. They would also enlarge our responsibilities, because every door we cut becomes part of someone else's weather. Even without them, the discipline we learn by trying shapes who we are. A species that tests the limits of law without kicking the legs from under the table, that dreams vividly and proves carefully. Perhaps that is the quiet gift wormholes have already given, a way to make our restlessness precise. They let us speak about far and near, before and after, same and different, using the grammar of geometry and the melody of quantum connection. They give engineers a problem whose difficulty enforces humility, and theorists a canvas that refuses sloppy strokes. And for everyone else, they offer an image worth keeping in the pocket, a doorway you cannot yet open, set in a wall you are still learning to name, reminding you that reality is richer than habit suggests. The story doesn't end here. It never does, with honest questions. The next one leans in with the shyness and boldness of a first greeting, asking not just about bridges, but about neighbors, and how many kinds of silence a universe can hold. Are we alone under this wide, patient sky? The truth may be knottier than a simple yes or no. If quiet doorways are real, and a few civilizations have learned to tend them, their travels wouldn't leave the fingerprints we're trained to notice. No radio beacons, no grand scaffolds swallowing starlight, just private steps through private corridors, errands run without engines. From our vantage, that could look like absence when it's merely discretion. Or perhaps the night is truly empty of minds but ours, and the tools we're sketching bridges in geometry, not metal, are the ones we'll someday use to spread seawater and stories and songs across an otherwise silent archipelago of stars. That question braids itself with another that has shadowed us since clocks. What, exactly, is time? A wormhole turns the stream into a map you might fold. If closed time-like curves are permitted under strict conditions, then before and after become more like directions than commandments. The thought doesn't mock causality. It asks whether causality is local and sturdy, while global routes can wind in ways that surprise. Even if nature bars those loops in practice, the exercise loosens old habits in the mind, showing how deeply entwined space and time are, how easily our intuitions cling to straight lines in a curved world. Far ahead, beyond the patient lives of galaxies, the universe thins into a whisper. Stars spend their fuel. New ones grow scarce. Island cities of light drift apart under the steady push of expansion. In that lean future, bridges, if they can be coaxed into reliability, would be more than conveniences. They would be lifelines. A culture could step away from a cooling sky, move resources and memory from dimming suburbs to warmer neighborhoods, even stitch a federation of refuges that shares heat and chemistry across gulfs that ordinary travel could never cross. The thought has the hush of last embers and a hand extended. Set beside these horizons is a softer, grounding question. Can we ever know enough to say we've finished? Wormholes remind us that reality keeps extra rooms. Each answer opens a door, that opens a hallway, that opens a field. You don't measure progress by arriving at an end. You measure it by how much more coherent the world feels under your fingertips. The search itself becomes a kind of cartography, turning blank spaces into notes about why they're blank, turning rumors into either landmarks or lessons about what the map will never hold. Whether or not they exist beyond paper, these bridges have already changed the furniture of thought. They gave artists a language for longing, and physicists a lens for law. They forced general relativity and quantum mechanics to sit at the same table and argue constructively. They sharpened the vocabulary of cause, information, and geometry. They taught us to imagine with guardrails, to let wonder and rigor share a pillow instead of picking a fight. The human motive, running under all this, is embarrassingly simple and perfectly honorable. We are built to wander, not because we are dissatisfied, but because curiosity is the way our minds breathe. The distances between stars look like walls, so we look for hinges. The equations do not laugh, they offer a few. The cultural echo is as potent as the technical one. A child touches a picture of a round doorway and learns, long before calculus, that impossible sometimes means not yet arranged. Honesty, though, keeps the light low and the words careful. Are wormholes real? The fairest sentence is still that we don't know. The mathematics allows them without flinching. The same mathematics exposes their tantrums and demands. The sky has not offered one to our instruments. The workshop does not have the materials in stock. In the years ahead, we might find that some quiet principle forbids them at human scales, pruning the family of solutions down to those that flicker and die before a photon can test the throat. Or we may corner a signature that refuses ordinary explanations, a lensing curve with the wrong symmetry, a gravitational wave with a timbre that doesn't match mergers or supernovae. Either way, the gain is clarity. The universe is gentler than rumors and stranger than habit, and both verdicts would honor that. If there's a dare tucked into this story, it's for those who will read it after us. If bridges can be built, they will be the work of cultures willing to practice patience as a craft, to temper power with caution, to maintain what they make the way gardeners maintain a path through a wild wood. If bridges cannot be built, the worth of the search will be visible in every instrument, improved along the way, every paradox untangled, every refined proof that keeps the rest of the edifice sound. All of this leans on a single, durable insight. Gravity is geometry. Einstein didn't just teach us how heavy things fall. He taught us that the floor itself bends when anything with energy walks across it. Before that revolution, space was a stage, time a metronome. After, the two became partners in a dance. Mass and energy tell spacetime how to curve. Curved spacetime tells matter and light which lines count as straight. Orbits are not leashes. They're the simplest paths in a warped neighborhood. From that insight flow both the darkness and the doorways. Black holes are the places where curvature becomes a cliff you can walk over but never climb back. Wormholes, if any are realized, are the places where the cliff turns into a tunnel. The same field equations, 10 interlocked relationships between curvature and energy, contain both sorts of shapes as legal sentences in their language. Solving those sentences exactly is rare. We have the simple, non-rotating case that describes a spherical black hole. Its rotating sibling, richer and more realistic. The smooth, cosmological solution that describes an expanding, homogeneous universe. Hiding in those forms are suggestive corridors. The old Einstein-Rosen bridge, in the simplest black hole picture, pretty but non-traversable. In the rotating case, a ring singularity that, on paper, makes routes into regions you might call other places. No one expects a traveler to survive the interior of a rotating hole. The tides and instabilities are not jokes, but the math's willingness to sketch such extravagances is a signal. It says we don't yet possess the full, merged story of small and large. At the core of each black hole sits a singularity, the point where curvature soars and the theory's confidence collapses. That breakdown is not a scandal. It's a sign that our map scale is wrong for that terrain. To protect the wider world from this ignorance, a great conjecture stands: cosmic censorship. It gently insists that singularities wear horizons like veils, that naked singularities do not parade in the open to confuse cause and effect. If that kindness is universal, we can study black holes with hope and without fear of logical catastrophe. Bridges complicate the etiquette. Some solutions that look like wormholes also host singular behavior in or near the throat, and not always in places decently hidden. If a passage could be kept open, would it expose a raw edge of the theory to outside influence? Would it violate the polite rule that the worst confusions stay quarantined? These are not rhetorical flourishes. They're sharp questions that dig at the border between allowed geometry and allowed physics. Against that tangle, another quiet revolution arrived from the quantum side. Stephen Hawking showed that horizons aren't perfect absorbers. Because fields in empty space are never truly still, pairs of quanta flicker near the edge. If one falls in while its partner escapes, the black hole must pay the bill by losing a sliver of mass. Over time, a time so long for large holes that the numbers feel like poetry rather than clocks, the hole radiates itself away. This turns the idea of a black hole from a closed chapter into a long, patient story with an ending. Small holes fade quickly. Stellar and supermassive ones take spans that dwarf civilizations and sometimes stars. Yet the principle is universal. Horizons leak softly. That leak changes the way we think about everything that touches a horizon, from information to energy budgets. It threads quantum field theory into curved space-time in a way that cannot be hand-waved, and it asks black holes to participate in the same conservation laws that govern gentler systems. It also places a lamp at the mouth of the cave where singularities dwell, hinting that quantum effects can alter the fate of the most classical of objects, not loudly, but decisively over time. And there, with the lamp lit, another cluster of questions gathers like moths and waits for a better union of ideas to settle them. Hawking radiation is gentle, but it's unforgiving. If a bridge leans on a horizon, does the leak unweave the lining? If the mass that supports a mouth dwindles, does the tunnel shrink and seal? Or can a passage persist as a freestanding thread once its anchoring hole has gone? If information is preserved in correlations rather than spat out explicitly, how does a bridge participate in that bookkeeping without contradicting causality? These are not the kind of puzzles you muscle through with will. They are the kind you cradle and turn in your hands until the facets align. They point straight at the marriage we still lack, the one that lets quantum rules and geometric rules write a single, legible paragraph about the same scene. Until that paragraph is written, we build smaller sentences, connect them carefully, and let the night be what it is, generous with hints, stingy with conclusions, comfortable with our small lights, moving patiently across its face. Hawking's soft glow raises a quiet tangle of questions for bridges. If a mouth is yoked to a black hole, and the hole slowly evaporates by leaking quanta into the night, does the throat thin along with it? When the last whisper of mass is gone, does the passage snap shut like a drying reed? Or can a freestanding tunnel remain an unanchored thread, tying two regions long after the anchor has dissolved? The math we trust at ordinary edges goes gauzy at horizons, where quantum fields and curved geometry negotiate. We don't yet speak the full language. Those puzzles wait on a deeper union, the kind of theory that lets gravity and the quantum write one sentence without arguing over the grammar. The same twilight is where our largest unknowns live, humming like distant machinery. Dark matter and dark energy, two names for we see the effects, not the cause, compose almost everything if you tally the universe by mass energy. One keeps galaxies together, lending unseen weight to their whirling disks and shaping the scaffolding on which clusters hang. We infer it through gravitational pull as reliably as we infer wind from grass, and yet no laboratory has caught a particle and called it by a proper name. The other is stranger still. Dark energy doesn't gather. It urges the fabric to expand faster, a persistent, gentle push that turns a mere drift between galaxies into an accelerating parting. It behaves like a pressure with the wrong sign, a kind of softness that, added everywhere, makes the whole sheet quietly swell. It's tempting to braid these mysteries with our yearning for bridges. A throat that resists collapse needs an outward lean. Dark energy, in its equations, leans outward on the grandest scales. Might the same sign help at small sculpted scales? Perhaps not. The cosmos often refuses to let a global habit be domesticated into a local tool. Still, the rhyme is intriguing. If negative pressure is part of the deep story, then the universe is not hostile to outward push in principle. Dark matter attracts like any citizen of gravity. Some speculative species of it could interact with geometry in unusual ways, but for now, those are sketches, not blueprints. The lesson is gentler. Ignorance is not empty. It is a storeroom where materials we don't yet recognize may sit, waiting for better eyes. Turn the lantern back toward information and the oldest argument in the cave. Drop a diary into a black hole, and general relativity shrugs. The writing crosses the horizon and heads toward irrelevance at the singularity. Quantum mechanics refuses the shrug. Information is not destroyed. It is transformed, scrambled, dispersed, but accounted for. Burn the diary in air, and the smoke, light, and heat still carry the pattern in principle. A black hole seems to take more than its fair share, unbalancing the books. To reconcile the ledgers, we've learned to think more like accountants of correlation. If the exterior fields and the whole are entangled, the lost pattern can live in their joint state, neither here nor there exactly, but recoverable in the right global accounting. The playful slogan, ER equals EPR, turns that abstraction into a picture. Entanglement is geometry's thread. A wormhole is the embroidery of that thread on the large. No traveler slips through those microscopic stitches, but information can ride in correlations without breaking light's speed limit. That isn't a proof. It's a direction, and whole landscapes of research have opened along it. Once you let geometry be creative, it's hard to make it stop at 4 dimensions. Some theories propose that our familiar 3 of space and 1 of time sit on a larger loom. Extra dimensions may be curled too tight to tour, yet rich enough to host structures that look impossible from our brain. In such rooms, tunnels can thread between sheets, connecting neighboring brains like hidden hallways between adjacent apartments. Stabilizing those hallways could be easier on a higher floor of reality than it is down here, or harder. The point isn't certainty, it's elasticity. When the stage itself can be more than it appears, The repertoire of bridges grows wide, and our job is to learn which plays the house allows. Then comes the shock of the hologram, a trick learned from black holes and exported to everything else with unnerving grace. The count of a hole's microstates grows with its surface area, not its volume. The data that make a region what it is might live on the boundary, like etchings on a skin, while the interior is an emergent story those etchings tell. If that's more than a metaphor, wormholes might be less like tunnels chiseled through substance and more like patterns in how boundary data are knotted. Entanglement across edges becomes stitching. The bulk, with its curves and throats, becomes the image cast by that stitching. Stand far enough back, and the picture looks solid. Step close, and you see threads, crossing and recrossing, a web of relationships that keep the whole from falling apart. In this light, a bridge is the geometry your mind infers when two patches of information are bound tightly together, a connection honest enough to guide, but too fine to walk. The story circles back to the very beginning, where heat and density made every second an era and every fluctuation a seed. In that stew, quantum foam could have boiled with fleeting tunnels, tiny mouths winking in and out of existence before language could attach a verb. Inflation, if it happened as our equations suggest, stretched tiny features to cosmic size in a heartbeat. It smoothed wrinkles into the evenness we see, but it also magnified the smallest patterns. If a few of those ephemeral bridges were pulled long before they popped, relic throats could still drift out there, rare as pearls but big enough to bend light in ways a diligent watcher might catch. We have not named one. The possibility keeps us careful with our surveys, skeptical of easy interpretations, and greedy for better instruments. It's one thing to draw a door. It's another to decide what it is for. If passages can be built or found, power arrives on silent feet. Distance ceases to police behavior. Trade, rescue, refuge, diplomacy, mischief, all become easier. The ethics are not side notes. They are the main score. How do you share access without creating empires of convenience? How do you protect quiet worlds from loud neighbors when arrival takes no time and leaves little trace? If time play is more than a fable, who bears responsibility for changes that propagate like waves through memory? The questions are not avoidable. With a shrug of, technology is neutral. Tools shape cultures, and corridors most of all. Safeguards would need to be woven into the hardware and the norms. Permissions that expire, audits that cannot be forged, physical constraints that prevent loops from growing long enough to tangle cause and kindness. The grown-up part of the dream is admitting that engineering a bridge and engineering its governance are the same problem at different scales. Underneath the blueprints and the constitutions flickers the oldest motive. Bridges are physics, and they are also confession. We don't like locked rooms. We prefer windows, then porches, then pathways. Ask a human heart what it wants, and it will often answer in geographies: to go, to meet, to return. Wormholes, real or not, give that longing a scientific accent. They let us ask better. If the world allows this kind of togetherness, what kind does it forbid, and why? If it forbids more than we hope, what gifts lie in the constraints? If it allows more than we feared, what obligations ride along? Meanwhile, the ledger of mysteries doesn't shrink, it matures. Dark matter continues to shepherd galaxies with invisible hands. Dark energy stretches the distances between island universes like taffy. Black holes glow, very slowly, and perhaps transmute into something gentler at the end. Entanglement lays paths no traveler can walk yet, and still manages to move meaning from here to there by reorganizing what here and there mean. Every new result narrows a corridor of possibility and brightens the lamps along it. Even a decisive no about traversable throats would be a brightening. It would teach us where the world refuses to bend, and those refusals are what give the rest of the structure strength. There's a humility to ending a long night's wandering without a trophy. A good map doesn't need a buried chest to be worth keeping. It needs landmarks honestly placed, distances measured with care, and hazards sketched without drama. That's what the study of wormholes has been doing all along. It has taught us to measure curvature like surveyors, to track information like accountants, to cradle paradoxes like tools that will be needed later. It has nudged cosmology into new friendships with quantum field theory, and it has asked experimentalists to look again at faint, fast things in the sky with a fresh suspicion that some of them might be more than they seem. And in the quiet just before sleep, after the equations and the ethics, there's the softest part, how the idea makes meaning feel roomier, not thinner. If space can fold, then separation is not a sentence. It is a condition that might be rearranged. If time can very nearly loop, then regret and hope are not opposites. They are notes in a melody we're only starting to hear. If the universe keeps both corridors and constraints, then trust can grow in the right places and restraint in the others. The world does not become less real when we learn it is weirder. It becomes more trustworthy because the weirdness keeps rules. When Hawking's glow meets a throat and we finally know whether the thread endures or breaks, other answers will line up behind it. If dark energy stays an unblinking constant or reveals a more intricate face, our sense of what can be propped open and for how long will sharpen. If entanglement maps continue to hint that space-time is woven rather than poured, we'll draw our bridges as patterns before we try to pour them as tunnels. If primordial relics remain undetected after our best searches, we'll tighten the net and admit the absence with gratitude, because a well-measured no is a kind of knowledge with backbone. There is an end to every night's tale, but not to the questions it sets gently on the windowsill. We are small creatures who learn to read the bends in a grand fabric and to imagine doors where there were only walls. Sometimes the doors turn out to be paintings. Sometimes the hinges are real. The work, patient, careful, stubbornly kind, makes either outcome worth the hours. Somewhere light years away, a star you will never see is fusing quietly, grateful for the same laws that keep your pulse even. Somewhere in your own chest, curiosity is doing what gravity does to space-time, shaping the room so paths become possible. If a bridge waits out there, we will meet it by walking well along the roads we already have. Better clocks, deeper surveys, cooler vacuums, cleaner qubits, steadier ethics. If no bridge waits, we will still have learned how to listen to a universe that speaks in rules, and how to befriend those rules without surrendering wonder. Either way, you can let your shoulders drop now. The cosmos is vast and strange, but it is not capricious. It rewards attention. It keeps promises. It leaves room for careful dreams. And in that room, tonight, the thought of a round, patient doorway can rest possible, impossible, beautiful while the steady machinery of stars and sleep hums on.